The value of a car V in pounds is modelled by the equation V equals AB to the power T, where A and B are constants and T is the number of years since the car was purchased. The line L, shown in the diagram, illustrates the linear relationship between T and log base 4 of V for T greater than or equal to 0. The line L meets the vertical axis at the point 0 log base 4 of 40,000, and the gradient of the line is minus 1/10. Part A, write down an equation for the line L. So it's a linear relationship, so it's going to be y equals mx plus c. But in this case, on our y-axis, we've actually got log base 4 of v. So let's swap that. And on our x-axis, we've not got x, we've actually got t. So let's swap that as well. We've also been told that the gradient is minus 1/10. So we'll have that. And we know that the y-intercept is log base 4 of 40,000. So there we go, we've got our linear relationship y equals mx plus c. That's part A done. Part B, find an exact form the values of A and B. So let's remind ourselves what A and B were. They are the constants in this model here, the V equals AB to the power T. So I need to work out the values of A and B. Well, I can do this a couple of different ways. I think the easiest, or the way I'm going to do it here anyway, is I'm going to take the equation I just wrote down and I'm going to do 4 to the power on both sides. If I do 4 to the power on both sides, then the 4 to the power of the log base 4 is going to cancel out to leave me with just V equals, and then I'm going to be able to compare it to this in a minute. On the right hand side, I've got the 4 to the power of the minus 1/10 t plus log base 4 of 40,000. And now I'm going to use index laws to split this up. The powers are being added, so that's the same as multiplying the bases. And again, here now I've got the 4 to the power of log base 4, which are inverse operations, so they're going to cancel out and leave me with just the 40,000. So now I've got the, let me just rewrite this with the number at the front. So the 40,000 times the 4 to the power of the 1/10 t, the minus 1/10 t. So I can see clearly that the A is 40,000 here. The B is within here. It's the 4 to the power of the minus 1/10. Which I could put into my calculator, but it does say it wants it in its exact form, the values of A and B. So I'm actually going to leave B as being 4 to the power of minus 1/10. That's exact. So that's one way of doing that question. As this video is a video here to help you, I'll show you the other way just in case you prefer the other way. So rather than taking the answer from part A and making it look like the original equation, I'm going to take the original equation and make it look like my answer from part A by taking logs of both sides. using the laws of logarithms to split the left-hand side up, and then using the law of logarithms to move my t to the front here, bringing the power down. And now let me compare what I've just written to my part A. I've got the log base 4 of A. Here I've got a log base 4 of 40,000. So from there I can say that the A has to be 40,000. And now I've got the t here times the log base 4 of B. I've got the t here times the minus 1/10. So therefore, the log to the base 4 of B would have to equal the minus 1/10. Therefore, B is equal to 4 to the power of minus 1/10. So that's the other way you could have done part B. Right, let's now move to part C of this question then. Bearing in mind we now know what A and B are. Part C. With reference to the model, interpret the values of the constants A and B. So, the 40,000 is the initial value of the car, or the car, the value of the car when t equals 0. So A is the initial value of the car. The B, the 4 to the power of the minus 1/10, well, that's the multiplier, that's the proportion by which the car decreases in value every single year. So numerically, the 4 to the power minus 1/10, we had to write that as an exact answer before, but if I actually work it out, it's roughly 0.87. So what that's saying is that the value of the car every year will be 87% what it was the previous year, or it decreases by 13% every single year. So I'd say B represents the annual proportional decrease. The annual in value. Part D, find the value of the car after 7 years. Well, we can just use our model here with t being 7. So 40,000 times 4 to the power of minus 1/10 to the power of 7, which will give us £15,157. Part E, after how many years is the value of the car less than 10,000? So if I take my expression, my model, and make V for 10,000, I'm going to make it equal to 10,000, then just say that t is going to be above that. So 40,000 times the 4 to the power of minus 1/10 t. If I divide both sides by the 40,000, 10,000 divided by 40,000 is 1/4. If I then take logs of both sides, bring my t to the front. And then I can divide both sides by the log of 4 to the power minus 1/10. And on our calculators then, we get 10. So after 10 years, the value of the car would equal £10,000. So during the beginning of the 11th year, the car would be worth less than 10,000. And finally, state a limitation of the model. Whole host of answers you could give for this. Some of them being model doesn't take into account accidents, or scratches or wear and tear. It doesn't take into fact that the value is not necessarily solely related to the age of the car. There could be other factors as well involved. So yeah, like I say, whole host of answers you could give for that, but the main thing I would say is that it's not necessarily going to be a smooth exponential decline.